Okay, so my name is Mallory Bartow. In this video, we're going to be exploring climate change, how they detect climate change and measure climate change, and then a few of the consequences that are a result we don't hear about every single day, and what you can do to do your part to stop climate change. So let's get started. I'm just so excited. This is my topic. This is why I went to engineering. This whole thing. I love it. I'm really excited. And I even wore my little flower earrings today. Okay, so we're going to be starting off talking about this guy named David Keeling. He was the first person to accurately measure CO2 levels, and he did this in 1957, and he decided to start measuring in Mauna Loa. But it's a volcano in Hawaii, and he decided to choose this place because obviously it's on an island. So at night you have these winds coming in and kind of refreshing all the air on the island, so it's not as stagnant. But then we also have less pollution because you're not near a massive city, and the vegetation didn't skew the data as much because it's on the slope of a volcano. And I know what you're probably thinking right now. You're like, wait a second. A volcano, those things emit CO2. How is he going to measure this accurately? Yeah, they thought about that. If it emits CO2, you're going to know. You're going to have this massive spike, and that's very different than that almost constant level that you're seeing or slight increase, over years, but it's going to be very drastic. You're going to see it. You're going to know, okay, this is from the volcano. And honestly, most of the time, they said this isn't even a problem because the winds blow that CO2 and some of the emissions away from the site where they're detecting anyways. Yeah, so now we have NOAA, which is the National Oceanic and Atmospheric Administration. And basically what they do is they keep this system going. They've been monitoring the CO2 levels in parts per million for 50 years. And so now we have this long stretch of time where we can see there's an increase in the CO2 in parts per million from 1957 to 2019. So how do they measure these CO2 levels in the first place? They do this thing called infrared absorption, which is kind of like they put air in a tube, and this is removed. They remove all of the moisture from the air, and then they put in this tube and they put infrared light in it, and the carbon dioxide will actually absorb some of the infrared light. So what they're measuring on the opposite side is less if there's more CO2, so you can kind of tell what's going on by that sample. So it's basically how many carbon dioxide molecules are present whenever you have all these molecules of air. Okay, so this graph is basically the recent CO2 levels on Mauna Loa, and it's over the last 5 years and going to end in 2020. You can see on the y-axis that we got the parts per million, and I remember when it hit 400 parts per million, it was a huge deal. People were freaking out, and that was in 2015, oh my goodness, and I'm looking now, and honestly I haven't checked since then, and okay, we are about to pass, 410, so that is very scary because I feel like that's a huge increase over not too many years. But the red line, you can see it's fluctuating. I kind of associate that with the changing seasons. So we've got our parts per million increasing over the winter months and then decreasing. It's kind of hard to tell from the graph, but I would assume it's from March to September. That's whenever the plants are, taking in a lot of carbon dioxide, and then they're not doing that as much over the winter months. So you see it's going up and down, but what matters is that average in between, and then you can see that it's increasing. And honestly, you might be like, why do I care about the CO2 level that's in the atmosphere? There's a relationship between the carbon dioxide and the temperature of our atmosphere, and it's because of the nature of the carbon dioxide molecule. So this molecule has the ability to vibrate and kind of have an uneven dipole, and basically what it's doing is it's going to take thermal radiation that's bouncing off of the Earth's surface, and then it's going to kind of capture it. Think of it as bouncing up, capturing it, but it's just vibrating that molecule and then releasing heat in exchange. So energy is always conserved, so it's trapping that heat in the atmosphere. And honestly, it's so complicated. I try to understand this process, and it's so easy to boil it down and make it simple, but it's so complicated. Like it gets really complicated really fast. So I think that's why why there's so much discussion on this, is because it's hard to understand in the first place. We all learned about greenhouse gas effects whenever we were in science, in middle school or in high school, and we learned that's why our Earth is warm in the first place. I think I read something that was saying that the temperature would be 100 degrees Celsius if we didn't have any greenhouse gases, and we didn't have this greenhouse gas effect that basically trapped the heat. And so we have this carbon dioxide, and there's so many other greenhouse gases. We have methane, carbon dioxide, even water vapor is, a greenhouse gas. But we like to focus on carbon dioxide just because it's easy to measure, and we have such a long span of data. Okay, so we can think of it as, let's say we have oil in the ground, okay, or natural gas or something, and whenever we burn it, it's releasing CO2. And it's just, think of it as like a control volume, and then we're just pumping stuff into that control volume. The atmosphere being the control volume, and we're just pumping in more and more stuff. Like, obviously the temperature is going to rise, and that's the way one of my professors broke it down for me one day, and it kind of made sense. I was like, oh yeah, like, he's like, you can't add something to a system and not expect a change. And we're like, okay, yeah, I guess that makes sense. But it always sounds easier when it comes from a PhD. Okay, so another weird thing about climate change, there's so many ramifications, because what we're doing is we're rapidly changing the environment around us. And I hear, one of the arguments that we hear a lot is that, oh my goodness, like the Earth is always changing, it's always evolving, it's always heating, cooling. Yes, it is. That's absolutely true. But I think what concerns people the most is not the fact that it's changing. It's not the change, it's the acceleration that it is changing that concerns people. Because, so let's think about it. Like, if last time there was an ice age, we had this change over a larger period of time. So there were animals that, yes, they died out, but a lot of them evolved. And it's much easier to evolve whenever you have, thousands of years, versus what we're doing now is basically changing in within 100 years, a drastic increase. And people are saying, oh, it's always changing. It's like, it's not. Like, it's changing, but you're looking at the rate of change. That's what's concerning. And that is where we're going to run into problems, because animals can't evolve that fast, that quickly, and our whole ecosystem is built around a certain way. We're going to talk next about something that is not as well known. I heard about it whenever I was first looking into all this climate change stuff and first getting interested in it, but then at the same time I was also in environmental engineering, and one of the carbon cycle, we actually learned about that in my classes. I feel like not as many people know about it, but it's acidification. The oceans basically take up about 25% of the greenhouse gas emissions that we put out into the air. The oceans actually absorb a lot of it, and it's nice on one hand because we have this buffer, and that's because of acidification. Okay, so we have atmospheric carbon dioxide that goes into the ocean, and it's dissolved and it mixes with water. So then we have carbonic acid, and as you can see, that is going to split into hydrogen ions. So that part right there is what's acidifying the ocean. The ocean is naturally a little basic, and this process is bringing it a little more towards neutral. Acidification is one of those things that we do not expect, and as a result of this, we have bleaching, coral bleaching. I know this is so sad, like, it breaks my heart. I went scuba diving in Curacao, and these are just like, our coral reefs are dying, like, we need to save them. And so they have the Coral Restoration Foundation, and so I got to plant some coral and just kind of help out. Yeah, so something I don't hear a lot about is the permafrost melting, and basically there's methane in the permafrost that's kind of been permanently frozen for some time, and whenever that starts to melt, it's going to release a lot of methane, and methane is another greenhouse gas that is actually more intense in trapping the heat than carbon dioxide. So once that starts to melt, we're going to just kind of enter into a big cycle of this permafrost melting, more methane released into the atmosphere, and then that is just going to increase the temperature more rapidly, and it's going to cause some problems for us. So there's all these little things and these little nuances that are happening, when you start messing with the environment. And that is one of them that I don't hear often. I don't know why, but there you go. So another thing that really contributes to global warming and climate change is the animal agriculture industry. There's been some debate recently, a few studies that have come out that argue like how much it influences. Basically some studies that, you know, at one time said that it was much more of an impact, and now it's saying it's a little less. So it's still up for debate how much, but we know that it is in fact a contributing factor. It plays a part, we just don't know how much exactly at this time. The huge thing you can do is just decrease your meat consumption. That's why I went vegetarian, and then once I did, I started looking at all these other reasons, like animal rights and health benefits. So you can't really lose. Like, even if you cut down a little bit, or even just cut down on beef, because that's a really big one, you could be helping the environment just in little ways. So it doesn't have to be all the time. You don't have to be as extreme as I am, but, you know, just little things. If you have maybe like a few days where you're not eating meat, I think that'd be really awesome and really beneficial. It could be really beneficial not only for the environment, but for your own health benefits as well. That's a whole other subject, but honestly it could really help you out, and so I just encourage you to kind of explore that, think about it. Also, you can recycle. I am an avid recycler, and I just really enjoy it. I feel like you have a better understanding of like where your product is going. It's once you start thinking of like everything you throw in the trash is going to a landfill, it's not just going into the trash bin. It really changes your perspective, and it allows you to think like, oh, okay, like this is going somewhere. It's going into the ground, and once it's in the ground, it's going to be packed in with all the other trash from everyone else, and going to be decomposing slowly and not with oxygen. It's going to be releasing a lot of methane. It's going to harm the environment. And every little thing you do, you have to think about, you know, what is the impact that it's having on the environment. There's big things that could help out, like corporations. You know, they release more than I do in a day, probably like in my lifetime. So if you have these beliefs and you want to encourage companies and plants to follow those same sort of ideals and really encourage them, that could be a huge step in the right direction. Another thing would be the tiny house movement. Those things are really cool. You know, people living in smaller homes, and you could honestly, if you live in that small of a home, you could be self-sufficient. So you could put your solar panels up top, collect rainwater, and not be connected to the grid in any way. And that's an extreme way of living as well. Or be minimalist. You know, you have to think of every single thing that you buy doesn't just appear like it was manufactured somewhere. It was shipped. It was then packaged, and like there's so many different things that go into a product. So if you think of a product as like, this is not just a cell phone, like it is so much more than that, because there are so many materials that go into it. Those had to be sourced from someplace, or the plastics had to be manufactured, and then the energy and the resources that went into that just to get into my hands is so much. And then what happens after that? You know, whenever I am done with this cell phone, am I going to just put it in the trash, or am I going to give it to a company that can reuse those materials? So we're cutting out a little bit of that process. There's just so much that you can think about, and it's kind of following the life cycle of an item. Another thing is, you know, in America, people who do not follow climate change and don't really buy into it, they are against the EPA. And I think it's funny because the EPA wasn't even created, you know, for a political agenda. It was created because of the pollution, and people were getting sick. People forget that the EPA is to protect us and not just, you know, go against corporations and make it hard for them. It's literally to help the people and to help the planet. And so if you think about it as something that's trying to help us, and it was made so that big corporations who couldn't place their factories in the middle of a city, and that pollution just being dumped into people, you know, constantly. If you think about it in a different perspective, I think it really helps. The best thing that I've seen recently is the hashtag trashtag. The hashtag trashtag. And it's basically where people just post pictures before and after of an area, and they have cleaned up the trash in between, and just makes my heart so happy. I'm like, yes. And I know a lot of people have done that, and then you've seen there'll be areas where actually, you know, it's really sad, or there's trash everywhere, and then they pick it up, and it's just really happy. So I know this was kind of like more sciencey, and then just like tips and things like that, but let me know what you think. Let me know what y'all want more of. If you would like to learn about an engineering topic in particular, let me know. If you would like to learn about what it's like to be a female engineering student for a day, or if, you know, like whatever you want to know about. I know somebody asked for how does a pressure cooker work, or like little things like that. Leave comments down below, subscribe, and let me know what you guys think. My name is Mallory Bartow. See you next Wednesday.